Thank you. And good afternoon and welcome back for those who are able to join us today. Normally when I prepare the AGM presentation, I focus on the big stuff, but this year is different because we get the big stuff every night on the 10 o'clock news. And so what I want to focus on this time is to talk about how that big stuff has influenced SinterCast, and more importantly, to look forward at our market development. And for me, I find that we just haven't had a lot of free running room in the last 2 years. It started with the COVID, then of course the semiconductor shortages, and now supply chain shortages in general. More recently, the political conflict and the war in Ukraine, and now inflation as well. And when we were together the last time in 2019, we presented this plot showing a really good growth trend in our market development. And these challenges have influenced and stunted our growth. It doesn't show the worst of it because this plot is based on the most recent quarter, so it's based on the first quarter of each year, and our low point was the second quarter of 2020. But overall, we've recovered, and generally we've recovered in parallel with the overall industry. And now I think that we're positioned very well to resume the growth. If we consider our outlook, semiconductors are set to improve. When it first started, the discussion was, will it span into 2022? And now obviously it has. And we're starting to recover. We hope that the supply will be better in the second half of the year, but it's clear that the effect will last into next year as well. On the positive side, there's a very strong pent-up demand. Since the first quarter of 2020, 12 million passenger vehicles have been lost from the global production schedules. In the US, it's estimated that there are 4.5 million passenger vehicles in pent-up demand, and we'll benefit from that in the near term. There will also be growth in our core sectors, so this is where we can start to outpace the overall improvement in the industry. We have the start of production of the new Scania 13-litre commercial vehicle engine. It started to report in February of this year. It will ramp up through the rest of this year and continue to ramp through all of next year. And we've also announced the start of production of a new 16-litre engine with First Automobile Works in China, FAW. It was supposed to have started before the end of last year. It's been delayed. We had some pre-production in January and February, but the FAW factory is in one of the lockdown cities in China, and they went into lockdown on the 14th of March and just returned to production on the 2nd of May. So it will be delayed. But I don't think that the interesting question is, when will it start? Because it will start. The interesting question is, what will the volume be? This will be the first 16-litre engine in China. And as the road infrastructure has improved, and as the owner-operators of commercial vehicles want to carry more payload to have a better financial result, FAW is introducing this new, larger engine. And it will be fascinating for us to watch how that develops. So that is in the near term. And longer term, you saw on the 28th of April and upstairs the display, we've launched this new concept for lightweight petrol engines, and it will be also fascinating for us to see how that develops in the longer term. I'll come back to that later in the presentation. Let's look at each of the individual market areas for our production, and with 44%, heavy-duty long-haul trucks are our largest contributor. And heavy-duty long-haul trucks will be our largest growth contributor. They will carry us from where we are today, around 3.3 million engine equivalents, to 4 million engine equivalents, and after that to 5 million engine equivalents, and beyond. And I don't know when I first said it, but certainly more than 5 years ago, and perhaps at this meeting, I said, in the fullness of time, all commercial vehicle engines will become CGI. And that's now becoming true. Today, many commercial vehicle engines are already CGI, and in the lead up to the next emissions legislation, which is in 2027, most of them will be. Last year in our annual report, the 2020 annual report, we showed this very strong consensus between AVL, FEV, and Ricardo, the big three engine design consulting firms. And they showed that in the near term, and when I say near term, I mean now and in the lead up to 2027 emissions, commercial vehicle engines will improve through an increase in pressure, about a 20% increase, a 10% increase in efficiency, and that will need more CGI, and the net result will be less CO2. The Diesel Technology Forum in the United States made an interesting calculation compared to previous generations of heavy-duty trucks. From 2007 to 2030, the newer generations will save more than 550 billion liters of fuel, which is the same as 1.5 billion tons of CO2. And that's equivalent to taking every passenger vehicle in America off the road for 1.5 years. And I think what's coincidental and interesting about their calculation is that 2007 was the first year for SinterCast to start production of a commercial vehicle engine. And 2030 is kind of our current window for watching the market development. So that's in the near term. Longer term, there's masses of development now with alternative fuels to make internal combustion engines cleaner, also with electric battery solutions and fuel cells. And I do get a lot of questions about what will happen in the market and what will prevail. And I think that the honest answer is that it's too early to tell. The 2020s are going to be the decade of development and evaluation. Evaluation of the technologies, evaluation of the cost and the total cost of ownership. And really, I don't think we know until we come to the end of the decade how it will ultimately split. And we have this quote from the CEO of Cummins to validate that. And he's speaking of electric electric powertrains for commercial vehicles. And he says, "We're trying to convince customers to try things, and the economics of it are not perfect. The technology is good, but it's not perfect. The diesel engine is perfect. It's 105 years of perfect." I'd like to say two things here. If we talk now about new engines being launched today, for example, like the Scania 13-liter, or the other new engines that will be launched in the lead-up to the 2027 emissions legislations, none of those OEMs are investing in the development of those engines to run for 3 years. They're running for the long term, and we will benefit from it in the long term, and we will also contribute to the environment in the long term. And again, quoting the Diesel Technology Forum in the United States, they forecast that in the US, diesel will still be the dominant powertrain for commercial vehicles in 2040, and I personally believe that they're right. Let's move to our second largest market area, which is the Super Duty pickups. I think the catchphrase here is strong and long. It's a very strong market, it's a growth market, it's a diesel market, and it will also be here for a long time. And when we speak of the longevity, I can refer to a quote from the CEO of Ford, who says, "We have Super Duty customers who do heavy-duty towing. It's hard for me to imagine that all of those customers will go electric in the next 10 years. Their use case is different from the way we've designed the electric vehicles." And that's certainly true. People need the diesel engine in these applications. And again, if we look at our contribution, the fuel efficiency of the diesel engine in these vehicles compared to the nearest available petrol engine, the fuel efficiency is 20 to 30% better. For the average Super Duty driver in the US, that means a saving of approximately 1,000 liters of fuel per year. So for our combined production for Ford and Cummins, We produce approximately 400,000 engines per year. It's more than 1,000 per day. And the net result of that is a reduction of approximately 1 million tons of CO2 per year. And how to visualize 1 million tons of CO2. And I'd like to refer back to one of my old professors from the university, and he said, think of a hot air balloon. And one hot air balloon contains about a ton of gas. So our contribution here is the equivalent of 1 million hot air balloons. And you can really visualize that. It's a big contribution, something that we can be proud of. Moving to the next sector, this is for full-size pickups, not the Super Duty pickups. That's approximately 13% of our market. We have 3 engines in pickup applications, 1 petrol and 2 diesel. The petrol engine in the Ford F-150 is the smallest and the most fuel-efficient engine option for Ford F-150. At the same time, let's look at passenger vehicles, because that petrol engine, being so efficient, has now been applied in other Ford vehicles, which brings us into what we call the passenger vehicle arena for cars and also for SUVs. And our petrol engine will grow. It's very popular. It's very fuel efficient. It's going in new vehicles. I think until for the next 10 years, we'll see a net growth in that engine. At the same time, the diesel engines will sundown sometime around 2027 and toward the end of this decade. I'm okay with that. They gave us our start back in 1999 in low volume and in 2003 in high volume. They gave us our opportunity to prove our technology. They've also given us 20 years of contribution. And when they finally sundown, the net cost to SinterCast will be about 100,000 engine equivalents. So if we're growing in the meantime from something like 3.2 million engine equivalents to more than 5 million, that includes the loss of those 100,000. So overall, it's been a real success story for us. And finally, we have production in what we call the industrial power sector for rail and marine and agriculture and construction. That also contributes about 4% to our total volume. We have very good references in this sector, but the simple fact is that it's smaller than automotive. And if we can grow that sector and keep it around 5% as the rest of the market evolves, I think that will be a very good contribution from the industrial power sector. We've just spoken about passenger cars, so let's look forward at the potential future for us in passenger vehicles. And you all saw that on the 28th of April, in conjunction with the opening of the Vienna Motor Symposium, together with Tupi and Ricardo, we launched a new concept for petrol engines. And we say a new concept for petrol engines, but what we really mean is a new concept for spark ignition engines. They can use petrol as the fuel, or biofuels, or synthetic fuels, or any net zero fuels. I'd like to tell the story of how that program started. So I was visiting Tupi, and this is back in 2017 or early 18. And we sat together and we said, we're really good with big engines. We're really good with commercial vehicles. We're really good with diesels, both V-type and inline. We have a high volume V-type petrol engine. The only sector that we haven't broken into is the small inline petrol engine. And so we decided to make a demonstrator program to show the potential of iron in those engines. We approached Ricardo. They had just finished development of a new engine. It's a 1.2 liter 3-cylinder engine, so it had just been launched. It was state-of-the-art at the beginning of our project, and they had all of the data about the performance of that engine, so we decided to use that as our so-called test mule. In the foundry industry, since I joined, the main way of weight reduction, it's a little bit to use a stronger material like CGI, so you can take a wall and make it thinner and it will still be durable. But most of the application was just making all of the walls a little bit thinner. When I joined 30 years ago now, in 1991, the minimum wall for engine blocks like this was 4.5 millimeters. And it had a range or a tolerance of plus minus 1 millimeter. And over these years, that's gradually been reduced from 4.5 millimeters, so that the V6 petrol engine that we use in F-150, producing more than 1,000 per day, the minimum wall is 2.7 millimeters. But as we sat together around the table, we said, going from 2.7 millimeters to 2.5 millimeters, it won't get us anywhere. You know, there's diminishing returns. We have to rethink and reimagine and reinvent the petrol engine. And that's what we did with this really novel concept. You can see that we changed the design of the block, so the bottom of it is like a barrel because it's a very strong structure. And then we replaced all of the outer metal with lightweight, low-density, durable plastics. And in the end, we developed a replacement engine which was lighter than the original aluminum engine. And I think that many of you will have seen this video that we had together with the press release, but here you can see an assembly animation of the block. These bearing caps are cast together with the block and then fractured off before they're reassembled. The ladder frame on the bottom is also produced in CGI to stiffen up the bottom end. And here you can see the plastic covers encasing the timing gear and all of the oil returns. And it has been very well received in the market. It was the talk of Vienna. We've been presenting it to OEMs. Everyone really appreciates and respects the novelty that we've brought to the engine, and it will be fascinating to see how it develops. Just in a small summary, so we effectively have the same weight as aluminum. Tupi has said that we think we could make it 3 to 5% lighter. The reason for that is that we took the original aluminum engine and we had to take all of the pieces out of it and put them back into the iron engine so we could build a running engine. And that meant that we had to keep all of the dimensions the same. But if we had a freedom to change the dimensions and to make it a little bit shorter, we could potentially take a further 3 to 5% weight out of it. The aluminum engine, as most aluminum engines do, has sleeves or cylinder liners to improve the wear resistance in the cylinder bores. We don't. It's a cost saving. In total, we have 54% less metal in the cylinder block. If you have less metal inside the cylinder block, when the piston comes down after the combustion event, it has to push the gases, the air inside of the engine, has to push them out of the way, yeah, because you have this resistance. It's like riding your bicycle against the wind. But when we have so much less metal in the bottom end, it's easier for the piston to come down. It reduces the friction. It improves the efficiency of the engine. We have somewhere between 5 and 40% better vibration performance. And although we didn't test noise, that will lead to a noise reduction for the fully assembled engine. We ran the engine in a proof of concept durability test for 100 hours on a test bench. And that included testing at full load. So think of driving this car up a hill, pulling a trailer at full speed for 4 hours. You can't do it in real life because you'd run out of gas. But that was a part of the test, and it passed. Manufacturing CO2, you've all heard our story about lower CO2 footprint for iron compared to aluminum. So we had 40% less CO2 in the manufacturing phase. And what the aluminum side normally does is by having a lighter weight engine, they can recover that manufacturing energy on the road because they use less fuel. But if the engines are the same weight, you can't possibly recover it. So this manufacturing footprint is the life cycle. And of course, cost advantages. Iron is always less expensive than aluminum. And that's really important because if you're going to use the engine also in hybrid applications, you have the cost of the batteries and the rest of the powertrain. So you have to make sure that the internal combustion engine is as cost effective as possible. And that's a contribution that we have brought. So I think that for this concept, it can be used as a standalone engine. It can be used as part of a hybrid powertrain package and also as a range extender for battery electric vehicles. So In summary, there's a strong market demand. We will benefit from the overall recovery, from the pent-up demand, from the improvements in the supply chain. There's a technical need for CGI. Whenever people try to push their engines harder, it's always better for CGI. Emissions legislations have always helped SinterCast, and they'll continue to do that. We'll have growth in our core sectors in the near term. We see now the launch of the Scania engine. There will be other commercial vehicles launched as we lead up to 2027. There's opportunities in new sectors, which is, of course, our petrol engine application. Electrification is here. Electrification will grow. I don't see it as a direct or an immediate threat in our core areas of heavy-duty and super-duty applications. And it may be an opportunity for us with our new petrol engine concept. I haven't said anything about installations in this presentation, and to be honest, it's because there's not much to say. In 2019 and 2020, we had record installation revenue. Last year, we had a really strong finish, trying to get things done before the end of the year to maximize our result. And the net result of that is that the pipe has become a bit empty. We have some installation discussions ongoing. There will be some installations this year. But for growth, this year we're going to have to rely on our series production, and the series production will carry us. And in closing, I'd just like to mention a word about our team. We have a very good mix of youth and experience in the company. Over the last year and a half, we've been developing our next wave of technical managers. They're in place. They're serious and sincere and professional and competent. It's a really good team. In the last 2 years, we have grown from 23 employees to 30. So for us, as a small company, it's a big percentage, and we focus now on getting everybody up to speed. If we look to our 10-year manning plan, and we do carry a 10-year manning and succession plan, we only call for 3 or 4 new recruitments in that 10-year period. So the team that you see today is the team that will carry us into the future, and knowing that team, I'm perfectly okay with that. Thank you.